Okay, so I had to do this project for my manufacturing class. We basically took three types of metals, steel, brass, and aluminum, and we had to test different types of cutting fluids to see how it affected the surface finish. In this video, I'll show and explain the process, and then make my conclusion on what fluid is the best for each metal. First, we tested steel with no cutting fluid. When face milling, we used a carbide face mill at 380 RPM with a depth of cut at 10 thousandths of an inch. We set the feed rate when cutting the steel too high, so none of the steel results look very good. We fixed this in later experiments with different types of metal. Not surprisingly, the results for using no cutting fluid weren't very good. The surface finish was rough with a lot of tool marks, but a part of this was because we set the feed rate too high. When side milling steel, we used a 9/16 inch 4-flute high-speed steel end mill at 679 RPM. Our depth of cut was 15 thousandths of an inch. Side milling the steel with no cutting fluid gave us a very rough surface finish. It was not aesthetically pleasing and definitely could have been better. Next, we tested Mobile Cut 100 coolant. This provided a better surface finish than using no cutting fluid, but it still had some small tool marks. But again, this could have been because of our increased feed rate. Next, we tested how the Mobile Cut 100 coolant would affect side milling the steel. This didn't make too much of a difference in the surface finish. I think it might have been because most of the coolant dripped off of the steel before we could make the cut. We then moved into face milling the steel with Hangsterfer CC22 cutting oil. It provided a pretty good surface finish considering the high feed rate. The tool marks were small and the surface didn't feel very rough. Next, we side milled the steel with Hangsterfer CC22 cutting oil. It had a nicer surface finish than the Mobile Cut 100, but it was still a pretty rough surface finish. The final face milling test for steel that we performed was with graphite. This didn't do much. It gave a poor surface finish, slightly better than using no cutting fluid, but not by much. And finally for steel, we tested side milling with graphite. Once again, this gave a poor surface finish. It was rough and similar to using no cutting fluid or Mobile Cut 100 when side milling. Next, we tested brass, doing the same processes. This time we fixed the feed rate so the surface finishes look better. We face milled the brass using the same carbide face mill as we used for the steel. This time we cut at 1200 RPM with a 10 thousandths inch depth of cut. The cut that's being shown now is using no cutting fluid. It had a decent surface finish because we lowered the feed rate. It was a little rough, but it wasn't as bad as steel. Next, we side milled the brass with no cutting fluid. We were left with a rough surface finish with visible tool marks and scratches. Next, we face milled the brass with the coolant. It left an okay surface finish. It was a bit rough with some visible tool marks. Then we side milled the brass with the coolant. It left a great surface finish. It was smooth and clean with minimal tool marks or scratches. We then face milled the brass with the cutting oil. It left a great surface finish with minimal tool marks or scratches. Then we side milled the brass with the cutting oil. It left a nice surface finish. There were some very small tool marks. Next, we face milled the brass using graphite. This left a great surface finish with minimal tool marks. It was slightly better than the CC22 cutting oil. And finally, for brass, we tested side milling the graphite. It left a good surface finish. It was slightly rough, but definitely better than using no cutting fluid. The final material we tested was aluminum. We used the same milling cutters that we used for brass. You are now seeing the face milling operation for aluminum with no cutting fluid. For face milling aluminum, we cut at 1050 RPM. Once again, our depth of cut was 10 thousandths of an inch. Using no cutting fluid left a decent surface finish. It was a bit rough, but it wasn't as rough as steel without cutting fluid. Next, we side milled the aluminum with no cutting fluid. We side milled the aluminum at 650 RPM with a 15 thousandths inch depth of cut using a 1 3/16 inch 6-flute high-speed steel end mill. Side milling the aluminum with no cutting fluid left a poor surface finish. It was rough with scratches and some tool marks. Next, we face milled the aluminum with the coolant. It left a good surface finish. It was smoother than the surface finish left by the cutting oil. Then we side milled the aluminum using the coolant. It left an okay surface finish. It was slightly better than using no cutting fluid, but it was still a bit rough. After that, we face milled the aluminum with the cutting oil. It left a pretty good surface finish. It was better than using no cutting fluid. Next, we side milled the aluminum with the cutting oil. It left a great surface finish. It was smooth with barely any tool marks or scratches. Then we face milled the aluminum with graphite. It left a smooth, shiny surface finish. It was the least rough of all the cutting fluids for face milling aluminum. And finally, we side milled the aluminum with graphite. It left an okay surface finish. It was a little rough with some tool marks. The goal of this experiment was to see how different cutting fluids affect the surface finishes of different types of metals when milled. Based on my findings, I can conclude as follows. For face milling, of the cutting fluids I tested, Hangsterfer's CC22 cutting oil provided the best surface finish for steel, and graphite provided the best surface finish for brass and aluminum. For side milling, of the cutting fluids I tested, Hangsterfer's CC22 cutting oil provided the best surface finish for steel and aluminum, and Mobile Cut 100 coolant provided the best surface finish for brass.